All right, hi guys. What I want to do in this video is I want to show you how to work the equations in worksheet number 11, which was assigned to you yesterday, Thursday, April 23rd. In this lesson, what I want you to do is I want you to be able to calculate the delta H value. In the last lesson, which were worksheets number 7 and 9, you were given a balanced chemical equation and you had to determine how to convert from one thing to another. But see how this is number 9, you were given a balanced equation and you were given delta H. What today's lesson wants us to do is to figure out what is the value of delta H. We're not doing these conversions, we're just looking to see what the value of delta H is. Okay, so in this worksheet, you have this table that's included in the worksheet. The table gives you heats of formation, and that just means how much heat or how much energy it takes to make this substance from its elements, right? And some of them, as you can see, are 0, and that just means it's in its most stable state, and that's not going to take any energy because it's stable. In order for us to find the delta H, we take the sum of the heats of the products and we subtract the sum of the heats of the reactants. So I wrote that out here, and on your worksheet I think I put it in brackets. Okay, so delta H is the sum of the heats of the products minus the sum of the heats of the reactants. All right, this is the first example, but I'm going to just go back and talk about the table a little bit. All right, so this is the table that you're going to use, and we're going to find all the numbers we need in the table. All right, so we have the substance listed, the heat of formation, then there's a blank, and then it repeats itself, substance and heat of formation. So for aluminum in its S state, S means solid, it has a 0 heat of formation. If I look at the next thing, it's Al2O3 with an S, that S means solid. Its heat of formation is negative 1676. Okay, so that's its heat of formation. If I look at bromine, bromine shows up twice. I have two Br2s, but one is a G for gas and one is an L for liquid. And the values are different. So when we're looking at our equations, if we need to look up a substance that shows up in our table both as a G or an L, we have to make sure that we pick the right one because the values, it does matter. The values are different. And that's what this part is telling you in here. Some of the substances can exist in different phases. Bromine can be gas or liquid, and then it just shows you. H2O is another one. Here's H2O liquid. Here's H2O gas, and they also have different values. So what we'll do, we will be given a balanced chemical equation, and we'll find the substances in this table, and then we'll look to see what their values are, and we'll incorporate that into our formula here. Okay? All right, so if we look at the first one, here's the first one here. Okay, I just recopied it onto the paper. The problem wants to know what's the delta H, or the enthalpy of the reaction, or the heat of the reaction. They all kind of mean the same thing. All right. So what I need to do is I need to find the values of these substances in the table. All right. Now, it is a balanced equation, so there are coefficients involved. And we need to incorporate those coefficients along with the heat of formation. All right, remember in the last lesson, we said that the delta H value relates to all of the coefficients of the substances. So when we're looking for delta H, we have to incorporate those coefficients as well. So the first value we have is CO. All right, here's CO, gas. So here's my table. I want to find CO gas. CH, there's all my CH. Oh, here it is, CO gas, negative 110.5. So CO gas is negative 110.5, but I've got two of them. So I'm going to multiply negative 110.5 times 2 to get the total amount, 2 times. And that gives me negative 221 kilojoules per mole, but I'll leave the units out for right now. Okay, so the next one I want to find is O2, so I'm going to go back into my table. So here's my table. So we're going to look for O2. It's probably on this side because they're all alphabetical. Oh, here it is right here, O2 gas. And this one just happens to be 0. Okay, so this one's going to be 0. There is no coefficient, but even if I had a coefficient, it would still be 0 because anything times 0 gives me 0. Now I want to look up CO2 gas. So go back to my table. Okay, so we're going to look and see. There's the C's, there's CO gas, there's CO2 gas right there. That's the one I want. So that's negative 393.5. So let's write this one down here. Negative 393.5, but you've got 2 of them. So I've got to multiply this times 2, and that's going to give me negative 787. So there's my numbers, 221. This part doesn't matter anymore. That, I'm going to keep it there just to put it into the equation. And this part doesn't matter anymore. These are the numbers that I'm going to use. Now, the equation says the sum of the heats of the products minus the sum of the heats of the reactants. So remember, here's my arrow. This side are the products, and this side are the reactants. So they're basically going to switch places. All right, so I'm going to start over here. So delta H is equal to, and I'm going to put it in a bracket because sometimes there's more than one, negative 787. That's the only one I have. So that's the sum of the product minus, I'm going to do another bracket, the sum of the heats of the reactants. So here's CO, negative, I'll say negative 221 plus, oops, I can put that little bracket there, I mean parenthesis, and then this is 0. I really don't need to include the 0, but just to show you. And then I can just plug all that into my calculator. So negative 787 minus negative 221 plus 0, and when I add all that up, I get negative 566, and the unit is kilojoule, if you remember that from the last. It's not per mole anymore because we've already used it in with coefficients, and that mole part kind of cancels itself out. So then, if you were asked, see here's my delta H, you could say my delta H is negative 566 kilojoules if they wanted you to put it back up into the equation. Here's my answer, there's my answer, same number. What if I asked you, is this exothermic or exothermic or endothermic? And what we do is we look at the sign. Because it's negative, we know it's exothermic. Okay? All right. So that was the first example. The second example, I'm just going to really kind of walk you through what's in the worksheet. So we're going to look at the second example. The reason I wrote the other one out is because here's my equations, this is the one we just did. What I did was I looked in the table first to find them when they were by themselves, one of them, and then the next part says now to get the value for the formula, we multiply our values by their coefficients. So here's where we did 2 times, 1 times, 2 times. See these numbers, negative 221, negative 787? Those were the numbers we ended up using in our formula. All right, and we still got the same answer, see? All right, so for this one, here's our equation. Okay, here's our balanced equation. Delta H equals question mark. And this is how they're listed on your worksheet. So you're just looking for delta H. You're not doing anything else. All right, So first find each substance in the table and then multiply by its coefficient. So what I did here was I consolidated these two steps and came out with my final numbers. All right, so C4H10 liquid, we looked it up. Here's all the C's. There's a C2. Oh, that's C4H10, but be careful, that's gas. Here's the C4H10 liquid. So the number I want to use is the negative 147, not the negative 124, because that's the wrong state, right? So negative 147.6, negative 147.6, and there are two of them in the balanced equation. So I multiplied it by 2 and got negative 295.2. So then I looked up oxygen. Oxygen, let's see, that was on this side. O2 gas is 0. So oxygen is 0, and we multiply by the coefficient. Again, you don't have to do this part if you know that it's going to end up being 0. I'm just putting it in to show it to you. So there's 0 times 13 gives me 0. Then I look up CO2 gas. So I think the COs are on this side. There's here's CO2 gas, negative 393.5. So this one is going to be negative 393.5, but there are 8 of them. So negative 393.5 times 8 gives me negative 3148. And then I look up H2O liquid. So let's see, that's F. Here's H2O gas. Oh, here's H2O liquid. Again, I have to be careful and pick the correct one. So they want me to use liquid. So let's go back over here. Here's H2O liquid, negative 285.8. So negative 285.8, and I'm going to multiply that by 10 because there's 10 of them in the formula, which gives me negative 2858. So these are the numbers that I'm going to use in my formula. Now I want to plug them in so that I have the total amount of product, and I'm going to subtract the total amount of reactant. Okay, so these are my products here. So these two numbers are my products here. And you don't have to worry about the units. Okay, so I'm going to add those up. So because I have more than one, I'm going to put it in a bracket, and then I put the second negative in the parentheses just to kind of help it add up the right way. But here we go. There's my negative 3148 plus my negative 2858 minus, now these are the reactants. Okay, remember the reactants here. So then these values here are the values for the reactants, and they're going to go second. All right, so bracket negative 295.2 plus 0. Clean up all your numbers. You should get negative 5710.8. So that's what the delta H value is. Or because it's such a big number, you can round it to a whole number and say negative 5711 kilojoules. Okay, so that's the answer to the problem. Okay, so that's how you do that. Hopefully that helped. You've got 3 problems. If you did them already and you were not sure what you were doing, hopefully this video helped to make it a little easier. If you didn't do them, hopefully the video will help you to do them. But what I'm going to say, I'm going to put this up in Canvas, and what I want you to do is watch this video and just do these 3 problems. If you did them already, then you're done. If you're not done with them, if you haven't done them yet, please do them and submit them to me so I can look at them. Okay? All right, thanks guys. Have a great day. Bye.